Within the first few seconds of playing a game, humans are able to pick out all the salient objects of the environment, and this helps immensely in finding winning strategies. Humans have a strong prior to focus on motion, which allows us to quickly identify important objects.
Our method, MOREL, short for Motion-Oriented Reinforcement Learning, embeds a prior for motion into a reinforcement learning agent. The agent learns to predict the movements of objects in the environment while learning a policy to maximize the discounted future reward. To do so, MOREL first trains a reinforcement learning agent in two phases. The first phase learns a structured representation of the environment in an unsupervised manner. The second phase uses the learned representation to find a good policy. Finally, the learned agent can be introspected by visualizing the object masks and inspecting their quality as the agent makes decisions during the game.
In the first phase, we collect a dataset by using a uniform random policy and recording the images that the agent was shown. Then we use this dataset to train a network to predict object masks, object motion, and camera motion in an unsupervised manner. The agent learns to warp one frame into the next by using the proposed object masks and object motion.
In the second phase, we transfer our segmentation network to train an RL agent. We add an extra path to track static objects. This is shown in the bottom path of the diagram. Also, as depicted in the top path, we jointly optimize our segmentation network with our RL agent. This allows us to refine the learned object segmentations as the agent explores more of the environment. Overall, we found that this improves sample complexity so that less data is required to learn to play the game. The diagram shows how our method is composed with actor critique RL architectures. However, in principle, our method can be composed with any deep RL algorithm.
In contrast to many black box, deep RL algorithms, our final agent also offers a degree of interpretability. Practitioners can look at the segmented objects to diagnose model strengths and weaknesses. Shown here is the Atari game Breakout, and on the right are the model's object masks superimposed in green onto the image which would have been given as input to our network. We see that it effectively tracks the movement of the paddle and the ball. By inspecting the quality of the object masks, practitioners can better understand what the agent has learned.
We measured the improvement in sample complexity on the suite of 59 Atari games when composing MOREL with A2C and PPO. With A2C, MOREL improved sample complexity on 26 games and performed worse on 3 games. With PPO, MOREL improved sample complexity on 25 games and performed worse on 9 games.
For full details, please see our paper, which is linked in the description. Thank you.